for those people that are not playing on their phone and hopefully came here to learn this morning, let's see if we're ready. So, class.
Yes.
All right. So, we have some people here that might actually be ready to learn, right? Joseph, you good? Okay. Hate to bother you. You guys okay?
Yep.
Is all right? Okay. Is Victor bothering you? Is that what the problem is? Okay. All right. So right here, antiderivatives. So what do you think an antiderivative is? Opposite of derivatives. So everything in math that does something in math has an operation that undoes it. So opposite of multiplication is division. Opposite of addition is subtraction. Okay. Opposite of power is root. Okay. Not just square, but root. Okay. So opposite of square would be square root. So yeah. All right. So antiderivative is the opposite of a derivative. Are you guys okay? Seriously? You guys all right? Okay. So, all right, right here, a lot of steps to go along with it. If a function capital F is called an antiderivative of the function of f. So, if we have a function f and we take the antiderivative of it, the notation is the capital F. So, if f prime of x is equal to f of x times f prime of x is equal to f of x for all x in the domain of f. So the corollary, if f and g are differential on a function and f prime is equal to g prime for all numbers in x. Okay, before we actually go too far, what does this mean? What would it mean if those two are equal? Yeah, there we go, right? Okay, so they're going to be parallel to each other. So for all numbers in x and interval from a to b, then there exists a number c from which that f of x is equal to g of x plus c on the interval. So, because if they're not, if there is no c, wouldn't that be the same line? Yeah. So they have to be different by something. Okay? All right, if function f is the antiderivative of f, f is defined on an interval I, then any other antiderivatives f has the form of capital F plus c, where c is an arbitrary constant. Now, where in the hell did I get that? Watch this. Let's say 2x squared plus 3x minus 1. Now, what we're going to do is, I stated that the antiderivative is the opposite. It undoes a derivative. So let's take a derivative. Y prime is going to be equal to 4x and what happened to that minus 1 over there? It goes away, right? It drops off. Now, let's do this step by step. To go from 2x squared to 4x, that was my derivative. I need to undo that. So think of the steps that I did to do my derivative. I took the exponent, multiplied it by the front, right? And then I did what? What else did I do here? Take the exponent, multiply it out front, and then I subtract the exponent by 1. So if that's the operation, that's the way that I did it, let's back that up. So what should I do first then? Add 1 to the exponent, so it would look like that. So it's going to be x, so it's 1 plus 1, right? And instead of multiplying by the front, what's the opposite of multiplication? Divide. So I'm going to divide this by, why 2? There it is, 1 plus 1. So there's my 2, right? Just so we can see where those are going. We just learned how to do an antiderivative there. Now, let's go to that 3. What did I do to that 3? Same thing. So what? Help me out.
So it should be 0 plus 1. 1 plus 0.
Okay. Is there a variable there?
No.
What happened to the variable going from here to here? So I add the variable, right? How many am I adding? 1. So I'm adding because it's not there, right? And now what do? Same steps. Divide by, which is? Very good. Now, the problem is, I have nothing over here. I have nothing over here. But now I have to go from nothing to some constant over here. But I have no clue how to get that. So there's a way that I imply it. There's a placeholder for it. That I know that in this one right here, since there is no variable, there must be a constant. And so putting it back to what it would be, I would be y equals, from here, 4 divided by 2, it's 2x squared plus 3x plus c. So we're not going to get exactly to the particular solution. If I were to get to here, this would be the particular solution. That would be a solution in which that I have an x and y that I could plug in to figure out what my c constant would have been. Yes, no, maybe? So, yeah. It's almost like I'm doing a whole new type of math here today. Nope.
It would just be a constant.
Just a constant, right? So it would just be a constant right there. So I would just put okay, so right here, I'm going to draw the circle for my derivatives. So it's going to be sine, cosine, negative sine, negative cosine. So if my derivative my d dx goes this way, my antiderivative, which is my integration, So that's a symbol for it. Goes the other way. All right, so we just work it backwards. So if I'm starting with negative sine theta, my integration or my antiderivative is going to give me capital G of theta is equal to positive cosine theta. Anything else? No? Victor, is this correct?
Yeah.
Kisnan, is this one correct? Huh? Maybe not. Angel, can you tell me why it's not correct?
Oh, constant.
Constant. Every time there's plus a constant. The constant might be 0, but I have to have a placeholder to say, because every time we do this, there is the possibility of some constant that was there. All right, this next one. So, same rules apply. So that's going to give me x to the very good, 3/2, because I'm adding 1. So I'm adding 2 over 2, right? So it's 3 over 2 over 3 over 2. Anything else? Plus c. This is where a lot of people are actually going to lose points on. I can clean it up. I'm going to clean it up. So if I'm dividing by a fraction, that's the same as doing what? Very good, multiplying by the reciprocal. So that means that this is going to turn into 2x to 3 over 2 divided by 3 plus c. All right, so your notes has a table. I know it looks kind of blurry. But if we work it backwards, if I go from right to left, this is actually doing derivatives. And then to undo the derivative, it goes from left to right. And that's going to be key, especially for these arcs. Those arcs. All right, functions f1 and f2 are antiderivatives of the function f1 and f2 respectively. Then f1 plus f2 is antiderivative of f1 plus f2, and f1 minus f2 antiderivative of f1 minus f2. An antiderivative of the sum of two functions equals the sum of the antiderivative of the functions. Antiderivative of a number times the function equals a number times antiderivative of the function. So it's like this. It's possible of actually having a constant times the whole thing. So you could basically factor out the constant or whatever, there's a common factor. If I could take a 5 out of the entire derivative, and then take the antiderivative, my answer would be 5 times that because I took it out to the front. So. It says find all the antiderivatives of this function. Now, that wording is important. All of it means that I'm going to get a equation that's going to have a plus c, which is going to be a value that I could plug in for any of my x's and y's that are on that. Now I'm going to show you with the graphing calculator here in a moment. And if you're looking at the book on this one right here, there is a typo. The one in the book actually has 6 over x squared. And I don't know if that was just in my notes, actually it has it slightly different, but the ones in the book go 6 over x squared. Well, we can do both if you want. All right, so we're going to do each item individually. So capital F of x, sorry. What's the derivative of e to the x? E to the x. So the antiderivative of e to the x is e to the x. Now, 6x squared. What am I going to do to that? Plus 1 and divide by that. So it's going to be 6x to the third divided by 3. And that negative sine x
would be
plus cosine. And am I missing anything? Plus my c. So on the AP exam and in calculus, so when you guys get to college and actually start taking calculus 2, that plus c is going to hit you every single time. You're going to get docked off points if you don't actually have it. Because if you don't have that c, it means something different. All right, can I clean this up? Yeah. E to the x to x to the third plus cosine of x plus c. And just for the fun of it, I told you there was a typo in the book, so if you're going back and looking in the book for this, if my function f, actually let me do it on another page. Function f e to the x plus 6 over x squared minus sine of x. So what I'm going to do is, I'm going to rewrite it first. Yep. To negative 2 minus sine x. So I rewrote it first, because that's going to help me with the math, right? So now, same steps apply. Be x to the negative 1, right? Because right now it's negative and I'm adding, so it's a negative 1. And then divide that by? By what? Negative 1. Okay, so when we have the negative exponents, that's what you have to pay close attention to. And this again is my plus cosine of x plus c. As I rewrite it, f of x e to the x minus 6 over x plus c. All right. Solve differential equations. So now we are going to solve these. An equation in the form of dy dx is equal to f of x is an example of differential equation. Any function y equals f of x for which that dy dx equal to f of x is a solution of the differential equation. The general solution, okay, this is important. The general solution, I know you guys are all paying attention and not trying to take a nap, is my plus c. The general solution is the one with plus c. The boundary condition, initial condition, is used in conjunction general solution to find the particular solution to a differential. That means that I'm going to give you an x and y to help you go back and find out what your c was. Blake, how you doing? You okay on that one? Okay. Solve the differential equation with the boundary condition of x equals 3, y equals -1, verify the solution. So, I'm going to go ahead and, with this, when I take the dy dx and I undo that, remember, it would be y would be the dy dx, right? Do you guys remember that or no? Okay, so that would be y equals, that's going to give me x3 over 3 plus 2x squared over 2 plus x and then plus c. Now, this is a general solution. And I'm looking for the particular solution. So particular solution means I have these when x is 3 and y is -1. So I get -1 equals 3 to the third over 3 plus 3 squared plus 3 plus c. Let's see, so that's going to be 9 plus 9 plus 3 is 21. So -22 equals c. Over 3 make sure I actually wrote that down correct. So x squared x minus 22. So that is my particular solution there. So I'm going to show you guys, so if you could please take out your calculator. This is going to be what it means. So, on my scratch pad. And for those people that already have lost their calculator, you can borrow one of mine as long as you don't steal it. Go to the graph. Now make sure you clear it. Do you guys remember how to clear it? You go Doc B, clears everything. Now menu, since it's already right here, I'm going to go menu, graph, entry, edit, and I want a differential equation. Writing these steps down might be important because you're probably going to forget in between now and then. All right, so differential equation, and if you notice it says y1 right here, and there's a little tick mark, that's referring to the derivative. It did. This one's my personal, so don't. So, I'm going to put my equation that I had. It was, let's see. So, my dy dx, x squared plus 2x plus 1. So, x squared plus 2x plus 1. Now, this next part right here is x sub naught, y sub naught. What that means is my initial. Whenever we were doing, I don't know, like the chemistry type of problem where we had like the growth and decay, where we have like an x sub naught, which is my initial amount. That's what this means. So x sub naught, y sub naught. So my points that I'm going to use right here, my x was 3, my y was -1, right? I hope so. Yeah, 3, -1. Now, this is what is called a slope field. A slope field is all possible slopes given a specific coordinate. The coordinate that we had was 3, -1, right here. This solid dot, 3, -1, that was my initial condition. So that's where, through all this, if I actually had any point that I could put on here, I'm going to have an initial condition for any point here, and it's going to move this to be a different point. So I'm also going to hit tab, go up, so let's say, for instance, I want to change my initial condition. Instead of having that, let's go 3, 0. Actually, let's see if I could do a 0, 0. There we go. By changing the initial condition, it moves the whole graph to be somewhere else. So we could solve for this and actually have an initial condition and have a line that goes through here. That's what that means is I want to find the point that my derivative, my equation of my derivative, my general solution, is going to give me a specific solution, a particular solution, given that point. Questions? No questions? So before we get into the higher order, I'm going to leave off today, so you guys could ask any question and try some of these problems. All right, make sure you all like, share, and subscribe.